Here's a video for notes 2-8, which is writing linear equations. So there's two forms that we're going to write linear equations in, and that's slope-intercept form and standard form. So we use slope-intercept form when the scenario has a starting point and has a constant rate of change. So really what we're looking for is a problem with two different quantities. We write the equation in the form y equals mx plus b, where b is the starting point and m is the constant rate of change. So when we're looking for a constant rate of change, we're looking for words like every, we're looking for words like each, and looking for words maybe like per. So when we see those words, that indicates we might be using an equation in slope-intercept form. So here's an example. It says Theodore recently started working at McDonald's so he could save up for college. He currently has $45 and earns $12 each hour. Write an equation to represent the amount of money Theodore has. Identify your variables. Okay, so I see two quantities in this problem. I see that he currently has $45. So in that case, that's actually going to be our starting point because that's how much he currently has. That's how much he's starting with. And then it says that he earns $12 each hour. So there's that keyword each. So that's going to be our constant rate of change. So now we can write it in slope-intercept form. And in this case, what we're writing the equation for, it says to represent the amount of money that Theodore has. That's going to be y. That's our response variable, or that's our dependent variable. Okay, so this equation is going to be written as y equals, the rate of change is going to be 12, so 12x plus 45. You can actually also write it the other way too. You can say 45 plus 12x, but just know that 12 is your constant rate of change, so that should be with the x, and the 45 is your starting point. Okay, we also need to define our variables. So y is the amount of money Theodore has. And x in this problem represents the number of hours he works. All right, so we can also have an equation written in standard form. So in this case, this is the scenario. We'll have two different quantities that equal to a total quantity. So in this problem, we're going to see these types of problems, we're going to actually see three different types of quantities. When I say quantities, I mean numbers. So it's written in the form ax plus by equals to c, where a would be the first quantity. This should actually say by. B is the second quantity, and c is the total quantity. So let's take a look at an example here. It says Barbara needs to earn $50 to buy tickets to see Monster Trucks later this month. She decides to sell homemade cupcakes. She sells chocolate cupcakes for $2 each and vanilla cupcakes for $1.50 each. Write an equation to represent the situation. Identify your variables. So starting with the first quantity, she needs to earn $50. So that's going to be the total quantity that she's trying to earn. It tells us that we're selling chocolate cupcakes for $2 each, so that's going to be the first quantity. And then it tells us that we're selling vanilla cupcakes for $1.50 each. That's going to be our second quantity. Okay, so writing this equation, first quantity is 2, so it's going to be 2x plus, second quantity is 150. 150y is equal to $50. Where x represents the number of chocolate cupcakes sold. Y represents the number of vanilla cupcakes sold. All right, let's look at a couple more problems. So it says Lorena is making friendship bracelets for everyone in her class. She can make 7 bracelets each hour and has already made 3 bracelets. Write an equation to represent the amount of bracelets Lorena makes. Identify your variables. So in this problem, I see only 2 different quantities, and I see the word each, which tells me that this is probably one written in slope-intercept form, y equals mx plus b. The 7 bracelets each hour is going to be m. And the starting point, the amount of bracelets she starts with, is going to be 3. So this equation is going to be written as y equals 7x plus 3, where x represents the number of hours and y represents the total amount of bracelets. Made. All right, this one says Carla is selling snacks at the varsity basketball game to earn money for her dance team's upcoming competition. She sells popcorn for $3 and nachos for $4. Write an equation to represent the amount of popcorn and nachos Carla needs to sell to earn enough money for her competition if it costs $200. Identify your variables. Okay, so I see 3 different quantities here. 2 quantities and then 1 total quantity. So the total quantity is the $200. One of the quantities is popcorn for $3, and the other one is nachos for $4. So this is going to be written in standard form. So it's going to be 3x plus 4y is equal to 200, where x represents the number of popcorn sold. And y represents the number of nachos sold. All right, this last one, it says Lorenzo has 50 cookies. He eats 3 every minute. Write an equation to represent the total number of cookies Lorenzo has. Identify your variables. So in this problem, I see 2 different quantities. I see that he has 50 cookies. And then I also see that he's eating 3 every minute. We're writing an equation to represent the number of cookies Lorenzo has, which in that case, that's going to be our y. So our equation is going to be y equals... so he's eating 3 every minute, and we're writing an equation to represent the number of cookies he has. So since he's eating 3 every minute, that tells us that this is decreasing, which means that this is going to be a negative 3. So it's going to be negative 3x plus 50. Okay, it also makes sense if you want to write it as 50 minus 3x. Might make more sense to some of you. But in this case, x represents... time, which is going to be minutes. And y, like we said, is the number of cookies Lorenzo has.